Now that we know some of the trigonometric identities, we're going to repeat the previous problem using the trig identities instead of the definition of the trigonometric functions on the right triangle. So, as we saw earlier, given the cosecant of theta is 13 divided by 12, find the sketch with the acute angle theta and find the remaining 5 trigonometric functions. So we start exactly the same way we did before. We're going to draw a right triangle with a 90-degree angle, and one of the smaller angles is equal to theta. We make sure the cosecant is going to be 13 over 12 by using the definition, and then we use Pythagorean theorem to get the 5. Okay, so we have an identity that says the cosecant squared of theta equals the cotangent squared of theta plus 1. That's one of the Pythagorean identities. And this one is going to be helpful because we do know what the cosecant squared is. We know the cosecant, so we know what cosecant squared is. We can solve this equation for the cotangent to get the answer without using, now see, we're trying to avoid using the opposite over hypotenuse, adjacent over, all those types of definitions on the right triangle. We're trying to exclusively use the identities. So, replace cosecant of theta with what they were giving us for that value, 13 over 12, and then square that 13 over 12. Bring down the equal sign, bring down cotangent squared theta plus 1. Now, isolate cotangent squared. It's equal to 169 over 144 when we square, minus 1, which is 144 over 144. We got a common denominator for 1. Now do the math, and we have 169 minus 144 is 25 on the top over the common denominator 144. So we have a cotangent of theta would be equal to plus or minus the square root of this 25 over 144, which is plus or minus 5 over 12. Now, we don't want two solutions. We have to recognize that since theta is in quadrant 1, all right, why do we know it's in quadrant 1? Because it's an acute angle. Its measure is such that it doesn't exceed the 90 degrees. In other words, it's between 0 and 90 degrees, or 0 to pi over 2. And so that means that all of the trigonometric functions in that quadrant are positive. That's a fact. So we're only going to keep the positive cotangent solution, the positive root. So that is equal to, because theta is acute, all the trig functions in the first quadrant between 0 and 90 degrees are going to be positive. We only keep the positive root. So that means that the cotangent of theta is equal to the positive 5 over 12. Okay, so here we were able to get the cotangent from the cosecant using the trigonometric identity. Now, let's move from there and recognize, well, what do we know about cosecant? Well, we were given that the cosecant of theta is equal to 13 over 12. And we know that that is the reciprocal identity for the sine. The reciprocal identity for sine would give us the reciprocal of cosecant. So it's going to be 12 over 13 for the sine of theta. And we just calculated the cotangent of theta equals 5 over 12. And we know that tangent is the reciprocal trigonometric function for cotangent, so we just flip the answer upside down to get 12 over 5. We're doing great. So what do we have left? Let's see, we have cosecant, cotangent, we have sine, we have tangent. We need the cosine function and its reciprocal function. So let's see, what is the reciprocal function of the cosine function? It's the secant function. Okay, well, why don't we use, we could use tangent squared theta plus 1 equals secant squared theta. We could use that. We know tangent. We're looking for secant. Okay, so replace tangent with 12/5 and square it. 12/5 squared. Bring down the plus 1. Bring down equals secant squared. So we square the 12/5 and get 144 plus 15 over 25. And then we rewrite the 1 as 25 over 25. Bring down the equal sign. Bring down secant squared. Let's turn it backwards. Secant squared of theta is 169 over 25. Well, that means that we could take plus or minus the square root and get secant theta equals plus or minus the square root of 169 over 25. So secant of theta is 13 for the square root over 5 for that square root. Now, you'll also notice that we just chose the positive square root because, again, in the first quadrant, in quadrant 1, that means for acute angles, the trigonometric functions are always going to be positive. So what are we missing now? We're only missing the cosine. That's the only trig function we need. Well, we know the cosine of theta is the reciprocal of secant, so it's 1 over the secant of theta. So just flip our secant answer upside down for the cosine. We get 5 over 13. And then we have 1, 2, 3, 4, 5, 6, all of the trigonometric functions, and we're finished.